Welcome students. In this lecture we shall be discussing about the concept of organogenesis, and later on we shall discuss about the fate of germ layers. Now once the process of morulation is over, then begins the process of blastulation, and then begins the process of gastrulation. By the gastrulation process, the three fundamental germ layers from which all the body organs are formed are established. These three germ layers are the endoderm, mesoderm, and the ectoderm. This establishment of germ layers initiates the final phase of the development, which we call as the organogenesis. Organogenesis simply means the formation of the organs. For the formation of the organs, we need the germ layers. Basically, all the organs of the body have their origin from one of the germ layers. That's why we need first of all the germ layers, and later on the organogenesis will start. So once the formation of the germ layers is over during the gastrulation, now the final phase of the development, that's the organogenesis, sets in. So in this final phase of the development, different organs are formed by the differentiation and the specialization of groups of cells. And we see that by 4 weeks after fertilization, we see that the embryo has a simple heart. It has simply the limb buds from which the limbs are formed, and it also has eye rudiments. Further, it has a tail and pharyngeal pouches, which are the vestiges of the early vertebrate ancestors. These tail and pharyngeal pouches later on disappear. After the second month, the embryo is recognizable as primate, and now later on, and now onwards, we use the term fetus for this embryo. Now, after that comes the fate of the germ layers. It means which of the germ layers forms what organs, and it is a fact that the fate of germ layers is same in all triploblastic animals. It also points towards the fact that all triploblastic animals have basically evolved from their common ancestor. Now, first of all, we shall discuss about the fate of the ectoderm. Now, what ectoderm basically, which organs basically are originated from the ectoderm. Simply, it gives rise to the epidermis of the skin. The outer layer of the skin is known as epidermis, and it is formed from the ectoderm. And it also has the epidermal derivatives like some of the glands and hairs and nails. These are all ectodermal derivatives, and they are also formed from the ectoderm. Similarly, nervous system is formed from the ectoderm. The middle part of the adrenal gland, that's the medulla of the adrenal gland, is also formed from the this ectoderm. Then the pituitary, which has three parts, that's anterior pituitary, median pituitary, and posterior pituitary. The posterior pituitary and the intermediate pituitary lobes are formed from the ectoderm. Similarly, a gland located in the brain, that's the pineal gland, it is also ectodermal in origin. Now, the eye has some components which are ectodermal in origin. If you can remember it by this C square LRI, C square means it's conjunctiva, cornea, ciliary muscles, and LRI means it is the lens, retina, and iris. These components have the ectodermal origin. Similarly, internal ear is ectodermal in origin. Then there is nasal epithelium, lining of the stomodeum and proctodeum. That's the lining of the upper part of the this digestive tract, and the last part of the digestive tract, that's proctodeum, last part of the digestive tract. These are lined by the ectoderm. The lining of external auditory canal, lacrimal glands of the near the eye, and salivary glands, they are all ectodermal in origin. And the outer layer of the teeth, that's the enamel, it's also ectodermal in origin. Now let's focus on the fate of the mesoderm. Mesoderm produces the dermis of the skin. Beneath the this epidermis lies the dermis, and this dermis is having its origin from the mesoderm. Similarly, most of the muscles in our body are derived from the mesoderm. Then connective tissues like the blood, bones, cartilages, all are the derivatives of the mesoderm. Peritoneal linings, kidneys, cortex of adrenal gland, gonads like ovaries, testes, urinary reproductive ducts, heart, blood vessels, lymph vessels, spleen, wall of gut, its lining epithelium, it's all this mesodermal in origin. Similarly, pericardium surrounding the heart, and pleura, visceral pleura, parietal pleura of the lungs, sclera choroid of eye, most of the skeleton, dentine of the teeth, mesenteries, and notochord. These are all mesodermal in origin. Then there's endoderm. Endoderm forms the lining of the gut, except that of the proctodium and the stomodium, which we already discussed that they are ectodermal in origin. Then gastric and intestinal glands are formed from the endoderm. Then tongue epithelium, liver pancreas, anterior lobe of the pituitary, thyroid gland, parathyroid gland, thymus gland, and the tracheal lining, bronchi, lungs. These are all endodermal in origin. Similarly, the lining of trachea, lining of middle ear, the primordial germ cells, and most part of the prostate gland, they are all endodermal in origin. Now, important point over here is that primordial germ cells, they are extragonadial in origin. That's they are not formed in gonads, they are formed in endoderm, then later on they go into the gonads. This is how the three germ layers form different parts of the body in the fetus or in the embryo.